Hi, welcome back to the course. In this lecture, we're going to completely dive into runtime memory. What does it mean? And we're going to look at different types of runtime memory, which is going to be really important. And towards the end, as I promised, we're going to look into why we are learning about these disk size, build size, and runtime memory in this course. Why is it important when it comes to game development? This video is completely theory driven, and there's no unity just yet. But this is an important topic, and I hope you learned something new today. Okay, welcome back. This lecture is going to be on runtime memory. This is the most important topic that we're going to cover, and this is what we'll be focusing on throughout the rest of this course. So, what exactly is runtime memory? It is a combination of system RAM plus VRAM. Okay, we've talked about RAM and VRAM before. Random access memory and video random access memory. But this isn't just as simple as that. There are different types of runtime memory, and it's important to understand each and every type so that you get a clear idea of how things work behind the scenes or inside your computer. Okay? Now, in my opinion, there are 7 types of runtime memory. Now, to be frank, you can't simply just categorize things into 7 types. There isn't any categorization. This is completely made up by me. But it is true to an extent. You can't divide it per se. They're all still memory. They're all still bytes and bits at the very end. But the way they're stored in the memory, the way they're accessed is completely different. And the way they're reserved. These are the different categories in which we'll divide them so that we get a good idea. Essentially, these are all combination of bits. Okay, that's it. Zeros and ones. Electricity and no electricity. That's essentially it. 7 types is something that's made by me so that things are a lot more clearer to you, so that I can introduce a structure to things that are not structured to begin with. Okay, there is probably more than 7 types, but I'm just telling you the important ones that will be important to us. Okay, so let's get into each different types. The first type is managed memory. Okay, important keyword here, managed. It's going to be very important throughout the rest of this course. What does it mean? This includes your C# objects on something called managed heap. You may have heard of heap and stack memory. This is one particular type of heap memory that is reserved for the managed memory in your game. I hope that makes sense. There are different types of heap memory. Okay, for each individual software, the computer reserves particular type of heap memory for that particular software. I hope this makes sense. C# objects. Objects meaning classes, related to classes. Object is an instance of a class. Classes, we're not dealing with structs. We're not dealing with things like int, floats, and everything like that. This is managed heap. Objects like references. Okay, this includes lists, strings, and dictionaries. These are important. If we say string name, this belongs to managed memory. Okay, so keep that in mind. This also includes your script references. If you have a reference of anything in your scripts, that belongs to the managed memory. Okay, both the object and the reference. If you don't know what an object is, let's say this is the player. The player itself is an object. But let's say there's another class that references the player. So let's say there's a player manager, and the player manager will have a reference to the player. Okay. If you have a 64-bit machine, this reference is going to be 64 bits or 8 bytes. If you have a 32-bit machine, it's going to be 32 bits. Okay. This is essentially the size. So that is the reference that I'm talking about. It is inside the managed memory. And the most important part of managed memory is this is responsible for all of the DC allocations that we have to figure out. Okay, garbage collection. The garbage collection allocation, specifically the spikes that you see in the profiler, managed memory is responsible for almost all of it. Okay, you need to keep that in mind. GC means managed memory, meaning our scripts. C#. Okay, great. The next type of memory is something called native memory. Okay, native. Please do keep note of the terminology. Managed and native is going to be very important. This term native essentially means something that is not ours. It's sort of like a neighbor. Okay, So the code that exists on the side of our code. In our case, for game development with Unity engine, this means the engine stuff. All of the memory that is required running the engine part of our game. Meaning, if you have things like textures, mesh, audio clips, audio source, animations, physics, rendering, particle, shaders, these are different things inside the engine that are part of our game. That is the native memory that I'm talking about. Let's say you added a rigid body component to our game object. That rigid body component will be a part of the native memory, not the managed memory. Managed memory is our custom code, C sharp. This essentially means no GC. Okay, there is no GC in native memory. All of the engine side memory is written in C++. This is different from your C sharp code. Okay, the native memory, all of the rigid bodies, the audio source, mesh, all of those components that you add, and all of the things that are used within the engine itself, like the animations, they are all non GC, meaning they're native memory. Okay. Next up is graphics memory. Graphics memory is your VRAM memory. We've talked about this before. This is very important because you don't see anything like spikes and stuff like that when profiling with respect to the graphics memory. We need to just work with the numbers here and see if there's any performance issues or bottlenecks. Okay, this includes things like GPU textures, shadow maps, GPU buffers, lighting data, render textures, all of those things that are needed for rendering. It's essentially in graphics memory. Okay, and yes, again, for graphics memory, no GC that we have to manage. Everything is managed internally because we have not written the code for it. I hope it makes sense. Now, the thing about VRAM, we talked about it earlier. Anything that is added to VRAM comes through RAM. Okay. If you have a texture, it is loaded into RAM first, then it is loaded into VRAM. Please do remember this point. Okay. This is because it is faster. If you worked with shaders, you may know this, which is why RAM requirements is always greater than VRAM requirements. Okay. This is always the case because of this reason. Everything that is loaded into VRAM is loaded into RAM first. Okay. Again, no GC, only managed memory has GC. Now, an interesting memory type is something called stack memory. We earlier talked about the heap and the stack. Okay. These are two different ways in which memory is stored. Heap memory is a lot more slower. Stack memory is meant to be shorter but faster. Okay. They work with different principles. If I want to explain it, stack memory work with the last in first out or the first in last out way of accessing memory. Okay, it's a stack. So basically, everything is like connected like this, and then not physically in the memory, but just for visual representation, the last memory that is added will be the first memory that is collected. So it is really useful. Okay, it is really fast. So that's how stack memory works. And there are different types of stack memory for each application in your project. Like it's reserved memory. That is too complicated. I don't want you to be too much worried about it. Let's separate heap and the stack. There is managed heap and there is managed stack. But stack completely, I just want you to group it as a single thing. It's not completely grouped, but it's also not categorized. I'm doing this so that it's easier to teach you. Okay. Stack memory, just think of it like that. This includes a memory for local value types. So things like integers, floats, vector3, quaternion, structs. Whenever you create a new integer, that memory is put inside stack memory. Because of this last in first out or first in last out principle, they can easily get that value very quickly. References and objects, they are stored in the heap. That is a lot more slower, but they use addresses and stuff like that. While this one uses the principle so that it's easier to get what we need. Also, things like local function memory. If you create a function and then if you create a local variable inside that function, that is also stored in the stack memory as well. Also, any form of temporary variables, whether it's inside a coroutine or anything like that, any form of temporary variables, they are stored in the stack memory. Very simple. Important one is structs. Structs are value types. They're not reference types. Meaning, if you do something like new on a struct, they won't generate GC. For example, if you say rigid body dot linear velocity equals new vector 3, this doesn't generate GC because structs is a value type. Okay, great. The same goes with things like quaternions or any struct that you make. The next form of memory is code slash executable memory. This is stored in RAM, obviously, and this includes the Unity player executable, the actual code or executable that we need to run the game. That is also part of runtime memory. This also includes your compiled assemblies, the DLLs, the things in your build that is necessary for you to run the game. Also, all of the compiled machine code as well. They're all just executable memory. Okay, they're necessary to run the game. Like I said here, these are just program instructions. And the thing is, we don't need to worry about this. This happens automatically, and we can most probably completely ignore this, especially when we are starting out. And yeah, these are things that you can mostly ignore for now until you get advanced and do a lot more stuff, which I don't think that you need to do right now. But please do be aware that these things exist, and these are things that you can find in your profiler as well. The next form of memory is static memory. These are memory for the static variables in your code. Now, this is important because they are still a part of the managed memory. Okay, but they're stored separately because they are static. I hope this makes sense. This is still managed. Okay, this is still managed memory. This is also something that we need to always be aware of. But they're stored separately inside the managed memory, that I'm putting it into a separate category because they are important to talk about. These are very important because we use them a lot. Static variables, they are stored separately. These are global states. Okay, so we need to be careful when working with static variables. Like I said, it's stored on the managed heap, and the way they are managed is important to be talked about. Okay, there's a reference and an object part of the static variable. If you write public static enemy E, right, E is the reference. Okay, so this is a reference, meaning they're like 64 bits. Okay, it's a 64-bit reference. It's a pointer to an address. When we say equals new enemy, I forgot the equals. Whenever we write equals new enemy or something like that, this is an instance of the class enemy. Therefore, this is an object. Okay, both of them are stored on the managed heap, but both of them are separate things to talk about. Okay, why am I talking about these things? And why are they separate even though it's still in managed heap, right? Let's say you have a level 1 where you have an enemy and you have the enemy E. Let's say this is a boss. Okay, let's say this is a boss, but it's still called enemy. We don't usually do this for a single enemy. I should have written boss here. So let's say this is public static boss equals new boss. Okay, we currently have an object boss here. This is the actual instance. We refer to that instance with E. Okay, this E. This is the actual reference. Okay, and this reference is stored in static memory, which is a part of managed heap. This object is also a part of managed heap. But let's say we change to level 2. Okay, this is very important. Please to listen carefully. If we didn't set E to null, okay, if we didn't set E, the boss, to null, this thing still exists even though there is no boss inside level 2 because these are global. This is one of the biggest drawbacks of working with static memory. You need to manage all of your references properly. So when we transition from level 1 to level 2, we need to set E for boss equals null. Now these two things are separate. There is nothing connecting to it because E is null. Because E is null and this thing is now disconnected, GC or garbage collector will clean it up. Okay. Now when we go to level 2, there is only a reference E here. There is no object. Okay. This happened because we set E equals null before we transition to level 2. This is very important because we might get wrong references if you're not careful when working with static variables. Okay, these are global things, they exist throughout your current game session. So it's important to talk about this. Okay, I hope this is clear. If you have any doubts or questions, please do comment down below. Now, before we talk about the next type of memory, pause the video and I want you to think, okay, what could be the next type of memory? Now, this is something that you may not think about when creating a game. This is going to be huge going forward when we come to creating a memory budget. When we are working on creating a minimum system requirements for a game. This thing is extremely important to be considered. And I want you to pause the video and think about it on your own. This is not me trying to show off, but me trying to emphasize the importance that this is something that we forget. Okay? This is very important. This is something that you already know. I'm very damn sure that you know what this is. So I want you to think about what is missing outside of your code, the engine code, the static and everything like stuff like that. What could be the one final missing type of memory? Pause the video now and think about it. Okay, so the thing that I'm talking about is operating system or OS memory. This is huge, okay? Because this is the operating system and it plays a part in the working of our game. Essentially, because things that are required to run the operating system contributes to system usage. Okay, this is OS reserved memory that we are talking about. This is very important for the functioning of your system in the first place. So things like drivers and file cache, all of those things, these are just two things that I can name. There's countless more. So why are we talking about OS, right? Because they run in the background. Okay, they run in the background and will be important when we talk about performance of your game. Operating system runs on your background. For example, if you were to make a mobile game on Android and you have a 4 GB RAM on your phone, we'll talk about this in detail later. Okay, essentially, estimated 2 GB of RAM is used already by the operating system. Okay, now you only have 2 GB left to work with. And still, even in that 2 GB, there's still a lot less that you can work with because of other background apps, right? It's just the OS. There's also other background apps that's running. There's also concepts like thermal throttling that we will discuss later in this course. Don't worry too much about it. There are so many factors so that if you're working on a game for a 4 GB phone, you only get like 800 MB or something. Okay, this is like how much RAM that you can actually reserve for your game. So this is huge, especially on mobile because they matter a lot. On PC, it's a lot more easier because you have huge amounts of RAM to work with. You can basically ignore a little bit. Your game requires 32 GB RAM. Your game should run well on 8 GB RAM. Okay. If you're playing a game, go to the task manager and see how much memory it uses. That'll give you a great idea. Okay. So this is very important. Operating system memory, I've saved it for last because it affects your game's performance and the ability to load the game as well. Now, we talked about this earlier. Why are we talking about these three types of memory? That is disk size, build size, and runtime memory. Why are we talking about these three things in the beginning of a memory course on Unity? Because each one solves a different problem. Okay, disk size solves storage, build size solves distribution, while RAM and VRAM, which is the runtime memory, solves runtime performance. They solve a different problem. Okay, and gone are the days where we had to worry about things like storage and distribution. Storage is widely more available. Years ago, if we have to make a game, disk size is an important thing to consider on top of runtime performance and distribution. Now, disk size is widely available. You have 1 TB HDD or SSD. We can make any game, basically. Disk size is no longer a big concern. It is still a concern, right? We talked about things like compression and all those things. We talked about import settings. It's still to be concerned, but still not as big as it once was. It's the same for the build, right? The engine takes care of building. Earlier, it was way more difficult. Imagine trying to build an Android game, which is already complex inside a game engine. Imagine something without a game engine. I don't know how you do that. But distribution is also solved. And RAM and VRAM, right? It's also essential for runtime performance. They both exist because they do different work and they work together to help with runtime performance. That's it. So there's a reason why we talked about all of these things so that we get a general idea of what essentially memory is and how it works on our PC. Now we can actually try and solve the problems that we face with each of these simple things. But before we do that, we need to talk about what garbage is and things like object pooling and some common questions that you may have going forward, which will be covered in the coming lectures. So I'll see you there.